Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about development of surfaces of the solids. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we have been provided with the construction of a funnel which is comprising of three elements over here. The element number 1 and element number 3. So these are comprising of square prisms having different dimensions over here. Element number 1, it is a square prism having square base 45 millimeter and height of the prism happens to be 5 millimeter. Whereas the element number 3, it is again square prism in which the edge of the base happens to be 15 millimeter while the excess height happens to be 25 millimeter. So both of these elements, element number 1 and 3, they will be developed using the parallel line development method. While the element number 2 of this funnel, it is represented as frustum of the square pyramid in which the base edge happens to be 45 millimeter while the top face square edge happens to be 15 millimeter. And the height of the frustum of the square pyramid happens to be 35 millimeter. So element number 2 will be developed using the radial line development method. Now with this information, let us proceed with the evaluation of development of different elements of this funnel over here. Now here, as we have discussed, there are three elements of this particular funnel. So corresponding to element number 1 and element number 3, the true shape dimensions of the base edge and the height of the prism, they are available with us. Corresponding to element number 1, the base edge happens to be square of 45 millimeter edge length while the height is equal to 5 millimeter. Corresponding to element number 3, the base edge happens to be 15 millimeter while the height of the square prism happens to be 25 millimeter. So this way we have already obtained the true dimensions corresponding to the base edge and the height corresponding to the square prism element number 1 and element number 3. Whereas in the case of element number 2, which is frustum of a square pyramid, now we can observe over here that these are the slant edges represented in the front view projections and these are the projections of the slant edges in the top view projections over here. Now the slant edges in the front view projections and the slant edges in the top view projections, they happen to be inclined with respect to horizontal plane and the vertical plane respectively. So we need to evaluate the true length of the slant edge of the frustum of this square pyramid so that we can carry out the development of the frustum of the square pyramid over here. Now here we have marked the 4 points of the base as A, B, C, D in the top view projections over here corresponding to the base of this frustum of the square pyramid over here. Now in the front view projections, points A and D, they will be projected as A dash and D dash over here in the front view projections. Similarly, the points B and C, they will be projected as B dash and C dash in the front view projections corresponding to the base of the frustum of the square pyramid over here. Similarly, corresponding to the top face of this frustum of the square pyramid, the 4 points, they have been labeled as A1, B1, C1 and D1 in the top view projections over here. And these 4 points corresponding to the top face of the frustum of the square pyramid, they have been marked as A1 dash and D1 dash into the front view projections over here. Similarly, the points B1 and C1, they have been projected as B1 dash and C1 dash in the front view projections over here. Now we can check the corresponding to the slant edges of the frustum of the square pyramid. Now the slant edges A dash A1 dash, B dash B1 dash, C dash C1 dash and D dash D1 dash in the front view projection, they are all inclined to the horizontal plane. Similarly, in the top view projections, the slant edges of the frustum of the square pyramid A1A, B1B, C1C and D1D, they are also inclined with respect to the vertical plane. So we have got the apparent length projections corresponding to the slant edges of the frustum of the square pyramid available in the front view projections and in the top view projections over here. Now we need to evaluate the true length of the slant edge of the square pyramid over here. Now here we have got the slant edge top view projection as OA. Now we have to rotate this slant edge OA into the top view projection so as to make it parallel to the vertical plane. Now once we rotate this apparent length projection of the top view OA and make it parallel with respect to the vertical plane, we obtain the point A2. So now the top view projection of the apparent length, it is now available with us as OA2. Now this edge, it happens to be parallel to the vertical plane. Now if we project it into the front view projections, now using the principles of rotation of the line method onto the locus line corresponding to the point A dash, the intersection of the horizontal locus line through A dash and the vertical projector line available with us emerging from A2 of the top view projection over here. So this intersection point provides us with the location of the point A2 dash in the front view projections over here. So now if we join O dash with A2 dash, now we have been able to obtain true length corresponding to the slant edge of this square pyramid over here. Now once we obtain the true length of the slant edge of the square pyramid over here, now we will be projecting the apparent length points corresponding to the frustum of the square pyramid, that is A1 dash, B1 dash, C1 dash and D1 dash onto the true length of the slant edge of the square pyramid over here, so that we obtain the true length corresponding to the frustum of the square pyramid over here. So this way the true length of the frustum of the square pyramid has been evaluated over here. Now we are going to proceed with the development of the different elements of the lateral surface of this funnel. So let us start with element number 1. So in case of element number 1, we know that it is a square prism having edge of the base is equal to 45 millimeter and the height of axis is equal to 5 millimeter. So now we are going to make use of principle of parallel line development method in order to obtain the development of the lateral surface of the square prism over here. So we can check, we have drawn two parallel lines at a distance of 5 millimeter from each other. And then starting from point A, we are going to start development of this square prism corresponding to element number 1 from the point A. So A to B distance will be 45 millimeter. Similarly, B to C, again the distance will be taken as 45 millimeter. Similarly, the distance between the points C and D and A, they will also be taken as 45 millimeter. So this way, we have been able to obtain the development of the element number 1, which happens to be a square prism having edge of the square base equal to 45 millimeter and height of this prism happens to be 5 millimeter over here. So here we have made use of principles of parallel line development method in order to obtain development of element number 1. Now let us proceed with the development of element number 2 using the radial line development method. Now we have already obtained the true length of the slant edge of the square pyramid as O dash A2 dash. Now we'll measure the length of the slant edge O dash A2 dash. Now using this true length radius, we are going to draw an arc having radius is equal to OA2. Now this is the arc which is having the radius OA2 over here, which is equal to O dash A2 dash. Now we know that the base of the square pyramid happens to be 45 millimeter edge over here. Now we are going to start from A2, then at a distance of 45 millimeter, we are going to mark the point B2. Again at a distance of 45 millimeter, we are going to mark the points C2, D2 and A2 over here. So this way we have been able to obtain the development of a square pyramid which has not been cut over here. Now we have also obtained the true length corresponding to the frustum of the square pyramid over here, and this true length we have evaluated as A2 dash and the distance up to the point A3 dash over here. So we are going to measure this distance starting from A2 dash to A3 dash over here. So once we measure this radius, now we are going to have the radius from the apex point, that is apex point happens to be O over here. So now we will be measuring this radius from O dash up to the point A3 dash over here. So once we measure this radius, now corresponding to this radius starting from O dash up to the point A3 dash over here. Now from O having the radius of this frustum top over here. Now we have measured this radius as O dash A3 dash. Now using this radius again we have drawn an arc over here, and we also know that this top face of the frustum of the square pyramid happens to measure 15 millimeter. So now from these points we are going to join straight lines over here, and this edge length will be equal to 15 millimeter each over here. So this point will happen to be A3, this point will be B3, this point will be C3, this point will be marked as D3, and this point will be again marked as A3. So starting point A3 and the last point A3 should be the same over here. And now corresponding to the frustum, the top face has been evaluated over here, and the bottom face or the base of the square pyramid has also been evaluated over here. Now we can join A3 with A2, B3 with B2, C3 with C2, D3 with D2 and A3 with A2. So this way we have been able to obtain the development of this frustum of the square pyramid, which happens to be element number 2 over here. Now let us proceed with the development of the element number 3. So we know that the element number 3, it is again a square prism having edge of the base is equal to 15 millimeter and axis height it is equal to 25 millimeter. So using parallel line development method, now we are going to proceed to evaluate the development of the lateral surface of the square prism. So we know that the maximum distance between the top face and the bottom face of the square prism happens to be 25 millimeter. So now two projector lines we have drawn parallel to each other at a distance of 25 millimeter over here. Now corresponding to the four faces, again we are going to start with point A. So it will be A1, B1, C1, D1 and A1. So 5 points we have marked over here, which are going to represent four surfaces of the square prism over here. Now the edge length between A1 and B1 will be 15 millimeter. The edge length between B1 C1, C1 D1 and D1 A1, so they will all be equal to 15 millimeter over here. So this way now we have been able to obtain the development of the lateral surface of the square prism having edge of the base 15 millimeter and height of the square prism it is equal to 25 millimeter. So this way in this problem we have made use of parallel line development method to obtain development of element number 1 and element number 3 over here, whereas the radial line development method has been used to evaluate the development of the frustum of the square pyramid, which happens to be element number 2 over here. So this is all for today. So I hope that through this discussion you would have understood about the procedure, how we can make use of the principles of parallel line development method and the radial line development method to evaluate the development of the lateral surface of the funnel, which is having multiple elements configured into it. So we are going to continue with further discussion regarding few more illustrative cases of development of surfaces of the solids in the coming lectures. So thank you very much. Thanks a lot.